Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson I will explain calculus application with the focus on volume problems. This is lesson 2 of 5. Have you subscribed yet? You can also visit my website onlinemaths.co.za. The link is in the comments below. There you will find all the chapters in the syllabus. Let's start with the maths. Example 1. Squares with size x are cut out of the corners of a square piece of metal. The piece of metal has length 8 centimeters. The sides are then bent to form an open top box. Number 1. Show that the volume of the container in terms of x is given by, and then I give you the volume there. Now first of all, remember the length was 8 and you cut out x and x. So the remaining length there will be 8 minus 2x. And then that side over there will also be 8 minus 2x and the height will be x. Now the volume of a little box is length times breadth times height, and then you can substitute in length's place 8 minus 2x times in breadth's place 8 minus 2x and times x for the height. Then you multiply out the brackets, and what I did was I wrote the x in front, and then the two brackets when you FOIL it out will be 64 minus 32x plus 4x squared. Then the next step I will multiply in the x, and I end with 64x minus 32x squared plus 4x cubed. And then in the last step what I did was I wrote the terms in a proper descending order. So there's your formula for volume. Number 2, calculate the value of x such that the volume is a maximum. By now you understand maximum minimum derivative equals 0. So there's the equation that you're going to maximize now. We will do dv over dx equals 12x squared minus 64x plus 64 is 0. And then you can divide by 4. 3x squared minus 16x plus 16 equals 0. And now we're going to factorize and make brackets. And remember, if you can't make brackets, then you may use the quadratic formula. The brackets are 3x minus 4. X minus 4 is equal to 0. And then x is 4 over 3, or x is equal to 4. But x is equal to 4 is not a solution, and let me quickly show you why. The length was 8 minus 2x. So when you substitute in x's place 4, you end with 8 minus 8 and a length of 0. And you can't have that. Example 2. A hat box in the shape of a circular cylinder is to be constructed in such a manner that the sum of its height and the radius is 9 units. Determine the radius for which the cylinder has the largest possible volume. And then there's a useful formula. The volume of a cylinder is equal to pi r squared times h. Now, the largest possible volume, this means maximum. So we need to find the formula, and then we will find the derivative equate to 0. Now, first of all, there's a little bit of information here, and that is that height, the sum, that's plus, of height and radius is 9 units. So that translates to h plus r equals 9. And then you can make h the subject of the formula, so that into the volume of the cylinder you can substitute into pi r squared h's place, in h's place the 9 minus r. Why am I eliminating r is because they say determine the radius. So we want r. We're going to differentiate in terms of r. Now in the next step we will multiply in the pi r squared and we end with 9 pi r squared minus pi r cubed. And now we have a formula for the volume that we're going to maximize. Therefore we will find the derivative. There's the formula. dv over dr is equal to 18 pi r minus 3 pi r squared is equal to 0. Don't worry about the pi. Remember, pi is a constant. It's just a number. Then in the next, and remember you also have to equate to 0 because maximum, minimum, differentiate, equate to 0. Then in the next step, I will take out 3 pi r as a common factor and I'm left with 6 minus r is equal to 0. And then 3 pi r is 0 or 6 minus r is 0. R is 0 for that one, and in this case r is equal to 6. Example 3. The sides of the base of a rectangular box are 3x and 2x centimeters respectively. The height is y centimeters. The box is open on the top. If the total surface area of the box is 200 centimeters squared, prove that y is equal to all of that. So we will start by finding a formula for the surface area. Now the surface area of that box consists of the bottom plus a left and a right side and a front and a back. These are the bottom, and then instead of left and right side, do you agree it's 2 times sides? And for front and back, it's as if you have 2 fronts. Now they are all rectangles. So for the bottom rectangle, it's length times breadth plus 2, and then the sides is a rectangle, length times breadth, and then the front and back is plus 2, length times breadth. Let's substitute. So when you go to the bottom, length is 3x times the breadth is 2x. For the sides, 2 times the length is 2x times and the breadth is y. And then for the front, 2 times the length is 3x and the breadth is y. And now we multiply. 3x times 2x is 6x squared. The second term, 2xy times 2 is 4xy, and 3xy times 2 is 6xy. And now you can add like terms. Therefore, 6x squared plus 10xy. So that is the formula for the total surface area. But it was given that the surface area is equal to 200. So you can equate to 200. So therefore 200 is equal to 6x squared plus 10xy. And then let the 6x squared walk across and we can divide by 10x and we end with y is equal to 200 over 10x minus 6x squared over 10x, which is y is equal to 20 over x minus 3x over 5, and that's what y is, and that's what they wanted. So from the previous slide, we know now that is what y is equal to. So the question here says, express the volume of the box in terms of x. Volume of a box, length times breadth times height. The length is 3x, the breadth is 2x, and then the height is y. But from the previous slide, remember here, we know what y is, and y is 20 over x minus 3x over 5. and what I said was 3x times 2x is 6x squared. And now I'm going to multiply in the 6x squared into both terms. And I end with 6 times 20 is 120, and then there's an x under the line. It will cancel with one of them, so that becomes 120x. And when I multiply in the 6x squared there, I will say 3 times 6 is 18 over 5, and then x times x squared is x cubed. And there's your expression for the volume of the box. Now the question wants us to determine the dimensions of the rectangular box if its volume is to be a maximum. So from the previous slide, we know this is the volume, and maximum, minimum, find the derivative, equate to 0. So we will find the derivative, dv over dx equals 120 minus 3 times the 18 over 5 x squared, and we equate to 0. Then I said 3 times 18 is 54. In the next step, I will multiply by 5 to get rid of that 5 under the line, and I end with 600 minus 54 x squared is equal to 0. Now I will solve x. So let the 54 x squared walk across, divide the 54 away, and now it's x squared, so you want x, therefore you take the square root, and you end with x is plus or minus 3,33. So obviously you will choose the positive one because it's the length of a side. And then therefore your dimensions will be, the length was 3x, therefore 3 times 3,33 is 9,99. And then your other length was 2x. 2 times 3,33 is 6,66. And then remember y was 20 over x minus 3x over 5. Substitute in x's place the 3,33, and then y's length is equal to 4. Now you know how to do calculus application, more specifically volume problems. Click on the video in the right-hand corner to take you straight to the next lesson. That one will be maximum and minimum profit in calculus application.